Welcome back. Hopefully it's a new day for you. If it isn't, then good for you getting all these AirPods done in one day. Even if it is Friday. I forgive you. Okay. Yesterday, we talked about square roots and how to do them, and today we're going to talk about square roots and how to apply them. So, one of the most common applications of square roots is something called Pythagorean Theorem, which sounds super fancy. In case you're wondering how that's spelled, Pythagorean Theorem. Super fancy. It's named after a Greek mathematician named Pythagoras, who discovered the applications of right angles along with hundreds of other things. But he's most well known for his theorem on right angles. So, in case you're wondering, Pythagorean theorem only applies to right angle triangles. That's it. So, we have three parts to our Pythagorean theorem. We have A and B, which we call the legs. I like to think of them as like a ballerina with her legs all up. That could be weird. Let's not think of it that way. Anyway, these two are called the legs. Legs. Okay? I don't know why. We just call them legs. This one has a really fun name. It's called the hypotenuse. Hypotenuse. Not hypothesis, hypotenuse. Why it's called that? I'm pretty sure it's Greek for something. But I actually don't know. This is the hypotenuse. It's the long diagonal side. It will always be the long diagonal side, and these will always be the legs. So this one is C. And that's what this equation describes. Probably should have led with that one. A squared plus B squared plus C squared is the theorem and the equation for Pythagorean theorem. What it's going to help you find is if I give you both legs, you can find the length of the hypotenuse. So if you watched two slides earlier, one of the most common ways you're going to see this applied is finding the distance from the top of a lamp pole to the ground. Anything slanted applies Pythagorean theorem, so like roof slants, Pythagorean theorem. Distances between things is often a use of it. There's a derivation of Pythagorean theorem that allows you to find the distance between 2 points. You will learn that in high school. Other than that, it's really finding just any side of a right triangle is how we use it most commonly in math. I will show you a couple notable examples of when I've used it in my real life and not teaching math class. So, first things first, though, we have to teach you how to use it before I can teach you how to use it. I know, I'm making no sense. Don't pay any attention to me. I'm going crazy. Been making videos for too long. Okay, so first things first, typically what we're going to do is we're going to give you two legs. We'll do that this whole week, and then next week I will show you how to do it if I give you only one leg and one hypotenuse. So, let's say this leg is 3 feet tall, and this leg is 4 feet tall. These are A and B, so we're going to fill them in for our equation. We're going to say 3 squared plus 4 squared equals this C squared that I don't know what it equals. Okay, C is our variable. We have no idea what it is. So, first of all, 3 squared is what? 9 plus 16 equals C squared. I'm running out of room, I realize. 9 plus 16 is what? Hopefully you tell me it is 25. 25 equals C squared. Now, you know in equations, what we do to one side, we have to do the other. And if I'm adding things in equations, the way to get rid of it is to subtract, right? If I plus 4, I'm going to subtract 4 and create a 0 pair. Kind of the same idea here. Except we're not going to create a 0 pair, we're just going to get back the original base, in this case, C. But we have this square here. I can't do anything with my variable until that square is gone. So what I'm going to do is I'm going to take the square root of both sides. Square root, both sides. Square root, both sides. Okay? Hopefully you can see that. It looks weird, but my screen's tiny and yours isn't. So, square root of 25 is what? Thankfully for you, it's a perfect square. 25. The original base is 5, which means that, you can see this, 5 equals c, because the square root of 25 is 5, and the square root and square cancel each other out. We're left with just c, just the original base. Okay, so in this case, it was a 3, 4, 5 triangle. This is one we call a perfect right triangle because it is comprised entirely of perfect squares, not a single not perfect square. We're going to do one more like this. Okay, I'm going to erase that so I have more room. Start with a perfect triangle, or start with a right triangle of some kind. Right triangle. We're going to say that this side is 12 and this side is 5. Okay, 12 and 5. Again, these are A and B because these are the legs. We have 12 squared plus 5 squared equals c squared. Ah, so much more room. Do that. That looks better. Okay. 12 squared, if we go over here, we don't have, but you should still have your perfect squares list up. And if you don't, just search perfect squares. 12 squared is 144. Plus 5 squared is 25. We learned that in the last one we just did. Equals c squared. Okay? 144 plus 25 is 169, which equals c squared. Now we're going to take the square root of both sides. Square root of 69, square root of c squared. These two cancel out, and we're left with just a c. Square root of 169, I don't know if you remember from the last video I did on, when did I do this? Yesterday, which was today. I did on calculators. The square root of 169 is 13. You can back that up using a calculator if you'd like to. So in this case, c equals 13. Okay? This is another perfect right triangle because it's comprised of entirely perfect squares. So, you can skip the rest of this. You don't want to find a nice little anecdote. But I have a funny anecdote that I've used. I've actually used this a lot. I don't know how many of you play Dungeons and Dragons. I play it quite frequently, and I am known as the math nerd of the group because of this, and I've done it 3 or 4 times since then. This was my very first time playing Dungeons and Dragons. So this represents a cart, a wagon, you know, of some kind. Little person here, little person here. And then there's this forest thing around us. And in this case, my friends and I are in the wagon in the game. And there are bandits in the forest all around us. Okay? They're going to attack us. Now, I have a bow. My bow can travel 60 feet. Should I shoot an arrow? Now, I knew that, let's say that we're like 10 feet from the forest, and then they're like 30 feet over, right? So I was asking my DM, am I close enough to shoot the people? And they were like, no, because that's quite a bit of distance. Actually, no, we were like 20 feet. Wait, I got this wrong. It was like 40 feet from the people and like 30 feet, sorry. So my DM was like, no, you're not within 60 feet. You couldn't possibly hit them. I'm gonna make this 20 feet. 25 feet. Yeah, anyway. I can't remember the exact statistics. I need to find the paper I wrote it down on. And I went, oh, really? I had all this data from her already, so then me being the smart person I am, took Pythagorean Theorem. I went, okay, 25 squared plus 40 squared is what? And we take out our handy dandy calculator. And we flip to the side, and I went 25 square root of 25, or sorry, 25 squared is 625. Plus 40 squared, which is 1,600. And we add them together. Plus 625, and we get 2,000 225. Remember, I'm just trying to get my c to be less than 60 feet. Take the square root of that. Sorry, square root of this is 47.1 feet. Haha, take that, DM. And that is how I killed the bandits without leaving the wagon. Using math. I've done this twice now. Most recently, there was a building. I was a sorcerer in my most recent campaign. And there's a building here. I'm down here. And there's this guy here that on his next move gets to stab me and I can do nothing about it. And I'm a sorcerer, so I'm a squishy. I have no way to fight back except spells, and I was out of spells. So, I know I can teleport within 30 feet. So I asked the DM, how far away am I from the building? And I did that whole thing again. It turns out I was 27 feet away from the building. And, yeah, I got the teleport on top of the building, and this guy did not get to stab me. He ran away in fear, because I just poof gone. Anyway, I know those aren't totally practical applications, but they have won me several D&D campaigns, so, you know, if you want to win a D&D campaign and you're a squishy like I was playing, knowing the distance of things is very helpful. Also, don't be a squishy. They get killed a lot. Okay, have a great day. I'll be on office hours. Remember, we always have fun Friday Kahoots. We played a random trivia Kahoot the other day, which was super fun. But if you show up, you get to tell me what Kahoot you want to play. So it can be literally about anything. We've done Twilight, Harry Potter, trucks, classic cars. I don't remember what we did last week, but it was fun. It was really fun. Oh, it was rats. We did one on rats, just for Jason. So, you guys come to decide. You get to choose. Come join us. It's super fun. You only have 2 more fun Friday Kahoots you can do. 2 more with me. You want to say goodbye, right? I know you loved me. I loved you. Okay, I'm going to stop making a fool of myself. Goodbye, guys.